All righty, and we'll give it just a moment more, and then we'll go ahead and get started. All right, so we are into our 13th week here. So we are going to be doing this assignment 11 is another regression assignment. Now I noticed there are 11 assignments on the syllabus, and so you're only required to do 11. I will have 2 more assignments that I will be posting this next week and the following week. Those will be bonus, and so if you have got points off or didn't turn in an assignment, after this one, it will be bonus. Actually, you really don't have to do this assignment in particular. You could do the one that's posted next week that's going to be on the last new thing we do, which is called reliability analysis. And so if you don't want to do this one, in fact, you can skip it and do the next one. You just need to do 11 assignments. So it will be out of 33 points, but you can get a maximum of 39 points if you do the additional assignments. And next week will be our last required meeting week. After that, it'll be based on individual meetings. I will have another regression type of task for people to do as a bonus assignment, and then we can meet on that. After that, the following week, I'll have the last exam. The exams, third exams, I still need to get those back to you, and the previous assignment that was due yesterday. Yeah, those will be coming back to you later this week. But that is the planning way for the rest of this course. And so 11 assignments is what's required, but there will be 13 total posted. That way you can make up for lost points, or you can just pad your grade if you'd like. So if people usually want to know their grade, I can get that to you after this exam is graded and your 11 required assignments are in, and I can tell you roughly where you stand. Obviously, the final exam, the fourth exam, will still need to come in, but after you've submitted your 11 required assignments, and that's all done, then I can tell you where you stand at in the class as a whole. Okay, so that's that. So we will be getting to the last required stuff, the new stuff, the last new stuff will be next week. This class right here, though, is just on regression. I think we need to look at this a little bit further. A multiple regression, that is when we have multiple predictors. We're going to be working with dummies variables today and doing some coding exercises. So when it comes to that, taking that last exam, let's all be multiple regression examples that people are comfortable or clear on what they're supposed to be doing here. So, okay, so I've got on Moodle, I'm going to share with you, if I can find it here. Is it up here? Okay. All right, let me know if you can't see my screen. You should be seeing the Moodle screen. And I am getting down to our assignment today. All right, so what we want to do.
Sir, I can't see that on the screen.
Oh, no, you can't. Okay, I wonder if it froze. Okay, so thank you. And okay, so we're on the Moodle page right now. Should be able to see the Moodle page right now, and we are going to be talking about recoding variables so that we can make some demographic comparisons here. And so what we want to use, this is going to be, a chunk of this is going to be a coding exercise. Return to some of that. When we are taking two variables and we want to combine them into a single variable to indicate their nationality and their ethnicity. So we're looking at whether or not people were US born, whether or not they identify as Hispanic. And so what we need to do here is first, we want to look at the variable born in the US, and we want to recode that And then we also want to look at the variable Hispanic, and then we want to recode that. And then after that, we are going to compute dummy variables, 4 dummy variables, using those 2 previous variables. And so we're going to make 4 mutually exclusive dummy variables. And so those are listed down below A, B, C, and D. Okay, so that's what we're going to do. So the first one we want to do is whether or not people were born in the United States. That's it, identified H1GI11. And let me go to, oops, let me go to my different screen. Okay. So let's look to see how that is coded, H1GI11. So this is whether or not people were born in the United States. We do have to recode this because the way it was coded, there is a no option, there's a yes option, there's these missings or refused, and then there's a legitimate skip, which means that they've always lived at their current address. They were born in the U.S., but they're skipped out of this question because of a previous question that indicated that they were U.S. citizens. And so what we want to do, we want to recode, we want to keep the no's, no's, we want to keep the yeses, yeses, we want to convert the 7s into 1s and then make the missings missing. Okay, and so basically the 7s are a problem here because these are U.S. born citizens, and we just need to put them into the 1 category. So the 1s are 1s, the 7s are 1s, the 0s are 0s, and the missing are missing. So to do that, we want to go into where it says transform, recode into different variable, display variable names, sort alphabetically. Then we want to go to H1GI11. Okay. And so we want to call that US born. Okay, and so if you were a 1, you get to be a 1 on the new variable. If you were a 7, you could be a 7, or sorry, you get to be a 1 on the new variable. If you were a 0, you get to be a 0. And then if you were missing, you get to stay missing. Okay, and so that made a variable US born. Okay, and then we can, let me get back to, let me run frequencies on this and make sure that that makes sense. That is, that it looks like what it should be. Okay, so right, we've got US born here. So the majority are US born. And so that looks like we did that correctly. Let me just check with something previously to make sure I did this right with a previous one. Yeah, okay. So I did this right before this class to make sure I don't make an embarrassing mistake. So yeah, so we've created one, a US born. So now we need to make another variable for whether or not someone identified as a Hispanic. So the ethnicity identifier we have to make. Okay, so let's go back to our variable view and let's H1GI4 is the variable that identifies whether or not person is Hispanic. And so we have recoding to do here. And so we just have to, again, take care of the missings. And this is largely, so we're relabeling this thing. Let's reset that and display variable names and sort alphabetically. H1GI4. Oops. Okay. And we're just going to call this one Hispanic. And this is largely so it's easier to find in our data set. And go ahead and hit change. Okay. Oh, I'll call it Hispanic 2 because I made this already. I'm just going to call that Hispanic 2 because I made that. Well, I'll call it 1. Okay. And old new values. So we want to say, okay, if you're 1, you get to stay a 1. If you're a 0, you get to stay 0. And if you're missing, you get to stay missing. Okay. And so there is how we make our two dummy variables initially. Let me go back and run frequencies on that again to make sure that did that right. So analyze descriptives, frequencies, and just look at our Hispanic 1 variable here. Okay, and so yeah, 743 people identifying as Hispanic in the sample. It's about 11.5% of the sample. Okay, so that's right. So what we want to do now is make these combinations variables that I'm showing here on the Moodle screen. So we want to use compute variable and then make a variable using compute variable that this US born non-Hispanic, this will be equal to 1 when this is equal 1 and this is equal to 0. And so US born 1, non-Hispanic, so Hispanic has to equal to 0. And so then we just repeat the step here, making this would be US born Hispanic, so this would be a 1 and this would be a 1. And then not US born Hispanic, this would be a 0 and this would be a 1. And then not US born non-Hispanic, these both would be zeros, right? So these are mutually exclusive, called mutually exclusive dummy variables. And you're making them out of two pre-existing variables that can be overlapping, right? Okay, so what we want to do this, we want to use the compute variable function within SPSS. Okay, and so let's go to up here where it says transform compute variable. Okay, we'll call this US born non-Hispanic. Okay, so that's going to be our largest category, US born non-Hispanic. Okay, so that is going to equal 1 when if these conditions are satisfied. If these following conditions are satisfied, they're saying, okay, so if you satisfy these conditions, you get to fall into this category. So if US born equals 1 and, oops, spell and correctly, and Hispanic 1 equals 0. So we US born, non-Hispanic. Okay, so if that equals 1 and that equals 0, then you get to be a 1 on this variable. Okay, so US born, non-Hispanic. Okay. It's okay, it's just, I've made the variable already, it's just telling me that I'm changing it. Okay, so that's how you do the first one. Okay, so we want to continue then, we can just go right back into compute variable and go US born and then take out the non and put Hispanic. That will equal 1 if these both, a US born and Hispanic, equal 1. Okay, and so make those both equal to 1 and go ahead and just repeat. Okay, yeah. Okay, and then we want to do it 2 more times. This time we want to go compute variable. We want to call it, it's going to be not US born and Hispanic. Okay, and so we want to go into the if statement again, not US born and Hispanic. So make that one 0, leave that one 1. Not US born and Hispanic, continue. Okay. All right, and now we want to go, last one, we want to go into compute variable again, and we want to go not US born and non-Hispanic. And then here, these will be both 0. Okay. So after we've done that, if we go and run frequencies on this, we'll notice they have missing values because we have to account for, we have to recode the missings as 0. So let me show you why we have to do this next step. If we run frequencies on our, let's see, US born, non-Hispanic, US born Hispanic, not US born Hispanic, not US born non-Hispanic. What we get here are, for these two, I've already done these first ones. So we're good here. So 0, 1, 0, 1. Notice that for US born non-Hispanic and US born Hispanic, because I already got rid of the missings previously. These two down here, notice you've got ones are taken care of. Those are correctly identified, but then you have a bunch of missing here. So we have to recode these missing at 0. And so in order to do that, a quick way to do that, you guys will have to do all 4 of them, but it doesn't matter. I'm just doing 2 of them. If there's a very quick way to do this, just to get rid of missings, go into where it says transform, recode into same variables. Okay, and then you will want to go into find your 4 variables. These are just the 2 I have to do, and put them over there. So these are the not US born Hispanic, not US born non-Hispanic. Put those over there into the box for recode into same variable. So normally we do recode into different variable. We're just doing recode into same. That way you just don't have to change the variable name. And then go old new values. If your system or using are missing, now you get to be a 0. So you'll appear in the analyses. You can go ahead and hit continue. You don't have to do anything else. It'll go ahead and take care of. So you're taking care of both of them. And so now should be, when we run this, we should see that all of these now they all have 0 1s. So so we got our 4 variables: US born non-Hispanic, US born Hispanic, not US born Hispanic, and not US born non-Hispanic. Okay, and so we get to look at how these 4 categories of combinations of ethnicity, nationality indicators are related to some outcome. And so I'm going to look at how these things are related to delinquency, if they are at all. And so we can do multiple comparisons of groups using dummy variables by leaving one of the mutually exclusive categories out as your reference group. What we'll do here, the typical practice is to leave out the majority or the modal category for your reference group. And so that would be US born non-Hispanics, and that's about 85.1% of the sample. And so they will stand as our reference group. So we're going to be comparing US born Hispanics, not US born Hispanics, and not US born non-Hispanics to everyone who is not that. And that happens to be US born non-Hispanic. So they will be the ones that are left out of the regression analysis. And when you have mutually exclusive dummy variables like that in a regression analysis represented by multiple dummy variables, the way that you get those you make a reference category is you leave the one out that you want all the others to be compared to in the model. So we're going to leave out US born non-Hispanic. Okay, and so when we go into analyze, we want to go into linear regression. And we'll go into Well, the delinquency item I already made. That's just the sum of those delinquency items. We've done that before, and that is the sum of those items H1DS1 through 15. And so that's listed there on Moodle, but I made that variable already. So I'm just going to put that in there. That's the delinquency scale that sums up all of those delinquency items, just the sum of them. And I didn't recode for missing or anything. There was very few missing there. I don't think it'll really affect the analysis anyway. So now what we want to do is put in all the dummy variables except for one. So we want to put 3 in. We want to leave out a U.S. born non-Hispanic as the comparison category. So we want to leave this one out. We want to put U.S. born Hispanic. We want to put not U.S. born Hispanic and not U.S. born non-Hispanic. So the one we're leaving out is the modal category, the most populated category in the sample. That's U.S. born non-Hispanic. And then we're going to go ahead and run our regression. Okay. And so what we get is this output here, where we're looking at essentially what are now comparisons of all these groups to people who are U.S. born non-Hispanic. Okay. And what you see here are, first of all, there are significant differences. And there are differences that are sometimes unexpected, or I guess less well known to the public generally. And so we can go through this stuff, and then I can show you what we do if we want additional comparisons, because this does not exhaust all the possible comparisons that we could compare. And so this is kind of like doing an ANOVA. But then you can add to this additional variables is what you can do for your homework. So if we look back at what's on Moodle, we're to ask we're to answer these questions. Who is more or less delinquent on average compared to U.S. born non-Hispanic? Okay, so that's what all of these variables are being compared to, because this is the dummy variable we left out, was the U.S. born non-Hispanic. Oh, who is more or less delinquent? So let's see how that turned out. Okay. Okay, so compared to U.S. born non-Hispanic, U.S. born Hispanics are about 1.5 points more delinquent on average, whereas U.S. born Hispanics, or not U.S. born Hispanics, I should say, not U.S. born Hispanics are about 1 point less delinquent on average than U.S. born non-Hispanics. Okay. And so are these differences statistically significant? Yes, they are. So they are statistically significant differences. Not U.S. born non-Hispanic, however, while it is less, the average delinquency score is lower than U.S. born non-Hispanics. It's not a significant difference. Okay. So there is a significant difference for these two groups when compared to U.S. born non-Hispanics, but not for this third group. And okay, so we can say that this group is more delinquent than U.S. born Hispanics are more delinquent on average based on the model compared to U.S. born non-Hispanics, whereas non-U.S. born Hispanics are on average less delinquent than U.S. born non-Hispanics. Okay, and we tend to see that with immigration generally. Immigrants usually have lower delinquency scores, crime involvement than U.S. born citizens, and so that comparison is noticeable here. And so this is obviously also taking into account ethnicity. And so you've got that that kind of comparison that can be made. Okay, so that's what those scores are showing. Let's take a look at what was else asked of us on Moodle. So what is the estimated difference in delinquency scores between Hispanics born in the U.S. and non-Hispanics born in the U.S.? What is the estimated difference in delinquency scores between Hispanics not born in the U.S. and non-Hispanics born in the U.S.? Well, that estimated difference in delinquency is what you are seeing in this model here. So the estimated difference between U.S. born Hispanics and U.S. born non-Hispanics is a difference about 1.5 points. The difference between estimated difference between U.S. born non-Hispanics and non-U.S. born Hispanics is about 1 point. Okay, and so this is the estimated difference between these groups. That's what, in this case, those beta coefficients are representing, because those are mutually exclusive dummy variables, and they are being compared to, well, they're being compared to 0. And so what 0 is just whatever happens to not be represented in the model. And so 0 in this case, what it's being compared, it's just always comparing it to the one level lower. It happens to be the group that's not represented in here. So it's going to be comparing it to the US born non-Hispanics. Okay.
Excuse me.
Yeah.
Okay, so on the homework and or the exam, do you want us to include the negative when asked for the difference, or does it not matter?
Yeah, well, that question actually was addressed in the previous two, who is more or less. And so you can indicate the sign in the homework, that's fine. But previously I asked who is more or less delinquent, and so you're answering it there. But I understand what you're saying. Yeah, that the difference, I'm just asking there for the difference in it. But you can say, well, this group is this much less or this much more delinquent by this much than this group. That would be very unequivocal. That would make it very clear that you understand the output. That'd be good. Yeah.
Thank you.
Yeah. So that is the difference here. So don't be confused. Don't think that I'm asking you to do anything else when I'm asking for the estimated difference here. Then just look at the output that's in the table. And so you just have to be mindful of which comparison is being made. Okay, and so let's look back at some of these other questions that can be addressed with this regression output. What group has the highest delinquency score? What group has the lowest delinquency score? So you don't have to write the regression equation out and solve it to do this. You will do that here in a second, but all you have to do is just eyeball it, and you can figure it out in your head who's going to be estimated to be the most delinquent. If you look at the output, this is the group that's above the comparison group. This is the group that's below the comparison group. And this is a group that's slightly below the comparison group. So the US born Hispanic is going to be the most delinquent. The least delinquent, it's going to be the not US born Hispanic, would be the least delinquent. And then the modal category, the US born non-Hispanic, is in the middle of the delinquency. They're ranked in the middle of delinquency. And so that's how you address those. And that's just by looking at, okay, this is the one this is above the comparison group because it's positive. This one's going to be below that comparison group because it's negative. And this one's not as low as the comparison group. So you know that you're looking at the highest estimated delinquency is got to be then for this group, and the lowest one has got to be for this group. And those differences themselves, we know, are also statistically significant, but this difference is not statistically significant. Okay, and so that's how you would address that by just looking at the difference in the comparison group from what's in the model. And we want to take a look then at what is Next here, okay, so write the regression equation. And so that's a regression equation, the same old regression equation we've been using, a y equals a plus bx, and then we have to fill in a and the b's. And so there's going to be 3 b's here, in fact, because we have 3 dummy variables and then just the one constant, okay? And so what I'm asking you to do is find the estimated delinquency score for a US born Hispanic. And so that would make it so that we have to fill in a 1 for the variable representing US born Hispanic, and then everybody else has to get a 0 because you cannot be one thing and another thing. These are mutually exclusive dummy variables. So if you are a US born Hispanic, then you cannot necessarily or logically be any of those other categories. And so when we do that, we're just going to be plugging in a 1 for that beta effect, and then a 0 for everything else. Okay, and so let me see. Can you still see my screen? Can people see? Okay, so I've got the equation here, and you can actually, if you double click on the SPSS output, it will allow you to just cut and paste the coefficients directly from there into SPSS. So it's no fuss. So you can just cut it and paste right into there. But then you have to go ahead and put in your addition and subtraction. So we got the equation here. So it's a plus a 1.5440. Now, actually, I want to make that it's going to be multiplied by either a 0 or 1 because that's what all these how all these dummy variables are measured. And so this is the 0.1544. That was for US born Hispanics. And so we want it for US born Hispanics. And so we want to make that a 1. And then the rest of these have to then necessarily become 0 because they're mutually exclusive dummy variables. They cannot be one. If you're in one category, you cannot be in the other. Okay, it's like anything else. Like if you want to make mutually exclusive dummy variables of what football team you want, and so, or what's your favorite football team, and then you want to compare everybody who likes the New England Patriots. If your favorite team is the Cleveland Browns, it can't also be the New England Patriots. These are mutually exclusive variables. It's the same thing that applies here. So if you get a 1 on 1, you have to necessarily be a 0 on everything else. And so what we're doing then is finding the estimated delinquency for someone who is US born Hispanic, because US born Hispanic, that beta coefficient was a 1.544. Okay, and so when we hit enter, when we do that, what we find is the estimated delinquency score for a US born Hispanic is 5.538. Okay, on a delinquency scale that if you run the frequency on it, it ranges from 0 to I think 45. So that is where the estimated average though is for a person with those characteristics. The next question asks, let me see, what does it say? It asks for, oops. It asks for, oh, let me go back to this. What is the estimated, or I'm sorry, find the estimated delinquency score for a non-US born Hispanic. Okay, and so in that case, all we're doing here is switching out what is going to be, I shouldn't be doing that, go into this. So we want to make this then, so not US born Hispanic. So this is this one that, got a negative beta coefficient. So it's that one. Okay, so we just switch this to a 0 and change this to a 1. So now we are representing the non-US born Hispanic. And their estimated delinquency score is clearly lower. It's 2.964. Okay. And so, yeah, again, these are mutually exclusive dummy variables. And so these are, you can use these are nominal variables. So you can use these in regression, no problem. You just have to dummy them up and decide which one is going to be your comparison group. And usually the comparison group is the is the modal category. It's the most populated category, or whatever theoretically makes sense that you'd want to compare this group to everybody else. Okay. So let's look back at, again, the Moodle page. The final question, how much of the variation in delinquency explained by the dummy variables? Well, that's the R-square statistic. The adjusted R-square statistic that we want to use because it's a multiple regression. And so if we take a look back at our output, if we go to this adjusted R-square, we see it's a 0.008, and so it's only explaining these indicators are only explaining about 0.8% of the overall variation in delinquency. So not much. So but at the same time, there are statistically significant differences. It's just that in the big picture, they don't matter that much. So this is one of these things that is hard to parse out sometimes in popular discussions about these issues of what it means to have a difference in groups and what it means for those differences to really tell us much about the overall thing that we're concerned about, like crime and delinquency. These are two very different things statistically. Mathematically, they're different things. And so this is a clear case of this. So it explains very little of the overall reasons or the overall variation why some kids are highly delinquent while others are not. But it matters. There are these group differences that persist nonetheless. Okay, so that is all I wanted to show you guys today. The assignment, what you want to do for the assignment is you want to keep going with this same thing. You want to add, though, to it the biosex variable, which is the indicator for gender, and then the variable for depression, felt depressed, along with those 3 dummy variables from the analysis above. Okay, so that's for the homework. I'm skipping ahead, though. Let me do this last one. I did skip over this. Take out US-born Hispanic and put in US-born non-Hispanic and rerun the analysis. Okay, because we did not exhaust all of our comparisons here because we don't have the comparison between the rest of these groups because we didn't compare the other one. So we can go stop sharing this. Let me go back to this and let's do this real quick. So you just go to analyze and go to regression and go to linear. And let's say, okay, well, I want the other comparison here that we didn't get. Let's take out US-born Hispanic and put US-born non-Hispanic in, okay? And then let's rerun this, okay. And so now we've seen all the comparisons, and now we can see, we can answer, what 2 groups have the biggest average difference in delinquency. And since all of these are negative, it makes it real easy. You don't have to do the arithmetic and write it out. It's the not US-born Hispanics compared to the US-born Hispanic. So it's within an ethnic group. Difference is about nationality. Is where the big delinquency differences lie when you look at groups. But again, the adjusted R-square, it went down a little bit because we switched out the reference category, but it's okay. It's basically telling us still, it explains very little of the overall variation, only 0.7%. And so that 0.7% is, again, how much the overall variation in the outcome delinquency is explained by these variables, but nonetheless, now we can see all of these groups. The most delinquent is the US-born Hispanic. All of these groups are less delinquent, but the biggest difference is really between the US-born Hispanic and and not US-born Hispanic. And so the not US-born Hispanic points has 2.453 points lower on average, estimated to be lower on average. Now, of course, these are group differences. They're within the group of not US born Hispanics, there is lots of variation in terms of delinquency scores. And logically there must be, because it does not explain a lot of the overall variation in delinquency. The model doesn't. So we know then we can logically infer that there's not much variation explained by the group differences. Much more of the variation must be then explained because of within group differences. So among people who are not US born Hispanic, there's going to be more variation there than between these groups. But there's enough variation between these groups to nonetheless produce these statistically significant results, because they are all statistically significant. Okay, and so again, that can be done with any dummy variables. Any set of dummy variables are mutually exclusive. You just want to leave out the comparison group. All right, so if there are any questions about that, you can stick around, but that is all for today. You can take a look at the homework, look at what I'm asking you to do is just add those additional variables to that, and then just answer those questions, and then that will be the homework. So, all right, folks. So that is all today. Take a look at that and let me know if you do have questions, but we will meet. Required last meetings will be Monday and Wednesday of next week. And then after that, it'll be individual meetings, and there will be additional assignments. So 11 assignments are required, but there will be 13 total that could be done. All righty, folks, I'll get your exams and other assignments back to you later on. Take care. If you would like to stick around for a moment, you're more than welcome to. Zach, why did you leave?